All right. Hey, everybody. In this very short video, I just wanted to briefly mention an awesome fact about parametric curves in the XY plane, which is that they generalize. And they generalize in a number of interesting ways. I mentioned this is sort of above and beyond what we need to know for class, but I mention this because I think it's awesome and I use it a lot in my own work and in some advanced classes. So how can these parametric curves generalize? Well, I've been talking about a parametric curve in the XY plane, right? So that's a two-dimensional, that's a curve, which can be thought of as kind of like a one-dimensional object. One-dimensional because it kind of looks like a line, but it's a curve sitting inside of two-dimensional space. And I can describe that with a pair of two equations, each involving a single parameter t. So we get this x of t, y of t, is our description of this parametrized curve. And all I want to point out is there's nothing that special about two-dimensional space. The reason that I have two-dimensional space is because I can describe it using two coordinates, an x-coordinate and a y-coordinate. And with a parametric equation, each of those coordinates is described as a function of time. So as time goes forward, or as my parameter flows forward, I trace out this curve in this two-dimensional, two-coordinate space. And so there is no reason why I cannot generalize this to 3 dimensions, or even to more dimensions, right? 3 dimensions, slightly easier to draw, right? We can talk about x, y, z, 3-dimensional space, right? You have to imagine that this x-coordinate is kind of popping out of the screen, sort of at you, 3D glasses on, it's coming out there. And so I can talk about a curve that lives in 3 dimensions. Maybe it starts here, and it sort of like wraps around, and it, whatever, is moving around in 3-dimensional space. Imagine a fly, if you want, sort of buzzing around the room. And this is tracing out a curve in 3-dimensional space. It again has a single parameter, t, and what it has then is not a pair of equations, but a triple of equations, x of t, y of t, and z of t. So 3-dimensional space is marked by the fact that it can be described using 3 coordinates, an x-coordinate, y-coordinate, and z-coordinate. And here I'm just saying that at time t, the position our fly is at is given by this triple set of equations. And we can generalize that not just to 2-dimensional space or 3-dimensional space, but n-dimensional space as well. We just lose our geometric understanding of what n-dimensional space looks like. At the same time, I can describe not a curve in 3-dimensional space, but rather a surface in 3-dimensional space by also using parametrized equations this time. And I don't want to get into any real detail here, but this time, if I have a space, 3-dimensional space, x, y, z, I can describe a surface, right, in x, y, z space, right? Maybe it sort of looks like this. Imagine a blanket or something that's been sort of thrown up into the air momentarily. And so that surface can be described, again, these are points in 3-dimensional space. And so we can describe their x, y, and z coordinates. And what's really interesting is that for a surface, which could be thought of as sort of a generalized 2-dimensional space, right? A surface is kind of 2-dimensional, the same way that a curve was kind of 1-dimensional. This could be used using, or described using 2 parameters, maybe a t and an s. And so we could describe x, y, and z, each involving 2 parameters. Here we lose a little bit of our intuition about time flowing forward, or sort of our fly tracing out a curve, right? It's harder to imagine tracing out the surface in time, but I will claim that we can generalize this idea of a parameterization to describe this surface as well. This is the topic of a more advanced math class, something that you might touch on in Calculus 2. I'm sorry, this is Calc 2, something that you might touch on in Calculus 3, and maybe a more advanced geometry of curves and surfaces type class, something that I am very enthusiastic about. So this whole video was more or less a complete aside. This is just a fun thing to sort of plant in the back of your mind that we can do these really cool things that generalize the notion of a parametrized surface. So thanks so much for watching. I'll see you all next time.